Okay, what we have here is there's two IQ tests, okay, and the all took IQ test too. So the same class took two IQ tests. The scores are on the IQ test are shown tables below. Now, just be clear about something. See the 86 and the 83. That doesn't mean the same student did both tests just because they're located on the same position. That also doesn't mean that the 104 on the first test and the 106 on the second test are done by the same person. It never states that. So that's an assumption if you made it. Okay, just to be clear about that. Now, what we're going to do is we're going to write down a couple of the numbers. So can somebody tell me what to write down beside the 8 on the left?
3.
Sorry? 3. What else?
That's 6 on the left.
3, 6?
No, that's 6.
Okay, Liam, will you just call them out for me yourself? 6?
It starts at 79.
Yeah, 9, perfect, thank you. After that, was it?
86.
Yeah.
89.
Yeah.
94.
Yeah.
96.
Yeah.
96 10.
Yeah.
97.
Yeah.
103.
Yeah.
104.
Yeah.
104.
Yeah.
105.
Yeah.
108.
Yeah.
111.
Yeah.
115.
5, yeah.
119.
9.
That's that for that side.
Okay. Other side?
Number for 17, that was 83.
Yeah.
94.
Yeah.
97.
Yeah.
97.
Yeah.
99.
Yeah.
102.
Yeah.
105.
Yeah.
106.
Yeah.
108.
Yeah.
108.
Yeah.
111.
Yeah.
111.
Yeah.
114.
Yeah.
117.
Yeah.
And 120.
120. Okay, guys. Now, what we did there was we arranged these tests, this test in order here, and these ones in order down here. Now, you haven't picked up full marks yet because you haven't put in your key. Now, key on the left is you pick a number. I'm going to choose 86. 6/8 equals 86. I'm on 13 out of 15. Anybody explain why? Have to do the other key as well. So this key here can be 8/3 equals 83. Remember, there's two keys when there's a back-to-back stem and leaf plot. Just one stem and leaf to the right, one key. Alright. Find the range of the IQ test. Everybody in the class got this. Your top score minus your bottom score. What's it? 119 minus? And what do we get? 40. And what about the second test? 121 minus? 120 minus 83, yeah?
37.
Now, what the range means is how spread out are your results. So, in the first class, you can see that it's 79 and 119. There's a bigger gap between top and bottom. And there's a smaller gap in IQ test 2 from top to bottom. Okay, 37 as opposed to 40. Okay, moving on. Find the median. Now, the median means the middle. How many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 numbers, okay? What's 15 divided by 2? Anybody 15 divided by 2? And because it doesn't go in evenly, round up to the 8th person. You find the 8th person in both lists. So you go down and you find the 8th person. 1, 2, 3, 4, 5, 6, 7, 8. 103 for that one. 1, 2, 3, 4, 5, 6, 7, 8. 106 in the second one. So 103 followed by 106. Yes, Higgins. Okay. Find the mean score. Anybody know how to get the mean? Or otherwise known as average score. Pretty much everyone in class knew how to do this. What you do is you add them all up together. So you add all these scores up together and divide by 15. You add all of these scores up together and divide by 15. When you do this, you're going to get 100.4, is it? Is that it? 100.4. And then 104.8. And some of you decide to round off to 105 and 100. Fair enough. Okay. Now, compare the scores of the two IQ tests. Refers to one measure of central tendency. A measure of central tendency is mode, median, or mean. Take your pick. What's a measure of variability? Range or interquartile range. So if you ever see that again, you might want to make a note of that now. When you ever see those words again, discuss your answers according to variability. That automatically means that you are going to use you're going to use your what's that word? You're going to use your range or interquartile range. If it says discuss your answer according to central tendency, you're going to use your mean, mode, and median. Okay, so let's. Sorry? Going to look that up. It's in the stats chapter. Full exercise or two on it. Okay, so just 1 second. The mean of IQ test 1 is anybody? I say we'll do it quick. The mean and median of IQ test 1 is, what's the mean and median of IQ test 1? 100.4 and 103. While
104.
Was it?
104.
Yeah, and while in IQ test 2 it's 105 and 106. Use the word respectively. Do you know what respectively means? It means in order. It'd be like saying Liam and Rory came first and second respectively. That means because I said Liam in front of Rory, that means Liam came first and Rory came second. Okay, so when I said mean and median respectively, it means the mean is the first score, the median is the second score. Okay, now this on average, this means that the results in IQ test 2 are better, right? Test 2 is better, while the range of IQ test 1 was 40 and IQ test 2 was 37. This means IQ test 2 had what's that word? A smaller difference between top and bottom, would you say, yeah? Any relevant points will get your marks between top and bottom. Everybody read that? Higgins, you had a question for me? Tell you something. Marshall says that every student in the class must have done better. Every student must have done better. Okay? In IQ test 1. Dan IQ test 1. Is Marshall correct? Now, let's assume we're a class, okay? And let's assume the story of a couple of people in your class, okay? So when you're doing this, you got to make up hypothetical situations to prove somebody wrong.
Sorry.
What if, okay? An example would be, I got 103 in my first test. I got 108 in my second test. I improved. The guy who came top of the first class, 119, he was sick the second day. He got 83 in the second test. Does that disprove Marshall's theory right there?
Yeah.
Only the averages went up. There's nothing specific about how each individual student did. So I could get 119 on the first test, followed by an 83 on the second test, means I didn't improve on my second test. Hence discount on his theory. Now, he could be right, as in, he could be right, because, but more than likely he's wrong. Somebody probably did slightly worse. Okay? So that's the answer to that was no. Because you can do better in test 1 than test 2. Yes, Fionn. This one here, guys, okay? Credit card, we have to count how many credit cards we have, okay? And first things first, we have to figure out what does each type of data mean. Anybody tell me what's numerical continuous? Give me an example of numerical continuous. Numerical continuous? Lim.
In a race, somebody came first, then next person came second.
That'd be more discrete. Max.
The times of their races.
Times of that race is perfect. So what Max is saying, that times are on a scale. So example would be, I did the race in 59 seconds. That's not true. I either did it at 58.61, or I did it 59.03. Do you ever make it in exactly 59 seconds on the dot? No. Even if you did, it'd be 59.00001. You'll never ever be 59 exactly with zeros as far as you can count. So what that is, it's a continuous data. It means that you're never exactly what you think. Another example would be, oh, I'm 78 kilos. Is that true? Is anybody ever exactly 78 kilos?
No.
You're 78.01, you could be 77.7, you round up and you round down, but you're never exactly there. That's how I recognize a continuous, numerical continuous. Everybody happy with that? Now, what about numerical discrete? Anybody give me an example of numerical discrete? Oddly enough, do you know shoe sizes? Even though shoe length is continuous, if you measure your feet, that's continuous, right? But because shoe sizes are very specific, so shoe sizes would be your size 3, your size 3.5, your size 4. Can you be a size 3.69? Doesn't exist, because a size 3.69 doesn't exist. Shoes are made specifically that they only go up in 0.5s. Is everybody happy with that?
Yeah.
Now, another example of a numerical discrete would be, how many tries did you score in a rugby match? You either score 1, or you score 2, or you score 3. You don't score 1.5. It's either your try or it's not. Hence, that's also numerical discrete. Now, the thing is, and all of these are numbers, right? Can anybody tell me what categorical nominal is? Categorical nominal.
It's like, I have a red card.
Yeah, it's like an example. What's your favourite football team? Some people say Liverpool, some people say Man United. There's no way of writing them, is there? They're random words, aren't they? What's your favourite fruit? Apple, orange, banana. It's all random. So this means random names. Random names would go very similar to what we have here, wouldn't it? There's no specific order, it's just a bunch of names of items. Everybody agreed with that? Now, what's the difference between categorical nominal and categorical ordinal? Yes, Alan?
One thing can be better than another.
Okay, an example?
Like results on the test or something.
That'd be like an A, B, C. Yeah. So I think what Owen's thinking there is A, B, C, D, E, F. That's technically categorical ordinal because there's an order to the words. Everybody happy with that? Can anybody else give me another example of ordinal? What type of house do you live in? 1 bed, 2 bed, 3 bed, 4 bedroom house, 5 bedroom house. Everybody got that? It's another example of an order. There's an order amongst the names. Right, cool. Yes?
Would it not be categorical ordinal then?
Okay. This is categorical ordinal because it has an order to them. Nominal is random names. Okay, thanks. Now, this is quite easy. How many credit cards do we have? Credit cards, anybody?
4.
4. Debit cards?
7.
Cash?
8.
Check? 1. Just remember that for me in a second. What's the mode of the data? Mode is the most common outcome. Cash. Very easy. Now, most of you got this right. John says he cannot find the mean of his data. Explain why this is the case. I'll give you an example, okay? Fionn, find me the average of 6 plus 4. 5. Find me the average of an apple and an orange. You can't because they're names. You can only find the mean of numerical data. It's not numerical data, therefore you cannot find the mean of it. Somebody said you can't add, subtract, multiply and divide words. That's a perfect answer. Okay? Because you simply can't. So hence you can't find your mean. Now, we're going to take this here and we're going to draw a pie chart. Pie chart was the most disappointing part of the test. Okay? Okay? We're going to construct our pie chart. Okay? Now, there's something you need to know. And a lot of you didn't show your workings for this either, which means you lost a lot of marks. The most common score is 8 out of 15. It means you drew a circle, you put in the names, and you made some form of attempt at it. Okay? Now, here's what we're going to do. How many items do we have in total? 9 plus 11? 20. Your credit card is worth 4/20. Your debit card, 7/20. Your cash, 8/20. And your check, 1/20. Is everybody happy with that?
Yeah.
With each one of these, you now have a full circle, okay? So you go to your protractor friend here, and you're going to draw your circle. Big nice circle will do you. Okay, now I don't need that anymore. There we go. That's all you needed it for. Okay, now multiply by what, guys?
360.
360. Each one gets multiplied by 360. Now what happens when you multiply them by 360? What's the answer for the first one, guys? 72? 126, 144, and the last one? 18. Now, you go to the centre of your circle. Don't remember where. Oh. Do you know when you initially use your compass? When you initially use your compass, you should probably find out where the centre of the circle is. I'm just going to say it's there. Looks roughly right, does it? Okay. Now, here's what we're going to do next. We're going to get Mr. Protractor out. And we are going to line it up. I'm going to do the 126 one first, okay? So see the way I'm going up? 40, 60, 70, 80, 90, 20. 120 is the same as 60. Go 6 to the left. And you have your 126 there. Once you have your 126 done, you just draw it going straight across. And then you draw it going straight up through that. Then just stop there. There's your 126 right there. What's the 126? It's the 7 out of 10. It's your debit cards. Okay. Then you go around again. I'm going to draw the next biggest one. I like to draw the two big ones first, because then it means I can really zone in on the other one. So 144, right? Oh dear. So 144. Let's have a look down. 10, 20, 30, 40, 50, 60, 70, 80, 90. There's my 140 there. Go up 4, around here. Okay, there's your 144. Once again, just draw it from here to here. See that line there, yeah? That's my 144 mark. Then you just rub it out, reverse. And that there is your cash. Finally, no colouring required, by the way. Just label them. Then go to your next one. You're going to line your compass in line with what you just did there a second ago. It's not perfectly in line just yet. There you go. What's my next one going to be? 72? Yeah. 40, 50, 60, 70, 72. Up around there. Some of you lost marks. It means that you're out by more than, let's say, a degree or two. You're out. You have to be within a degree or two. Some of you are out 3 or 4 degrees, and I couldn't give you full marks for that. Okay, and there you go. Smallest one is check. Second largest one is, oh, sorry, that's credit card then, isn't it? Everybody happy with that?
Sir?
Yeah.
Did I lose marks because I was slightly off there?
Yeah. Oh yeah, just a Margaret question, okay? Margaret wants to examine if people prefer their weekly shopping in Tesco, Dunnes Stores, SuperValu or Lidl. She stands inside her local Lidl shop for one day and asks everybody as to leave the shop, where did they prefer to do their weekly shopping? Give one reason why Margaret's data might be biased. Now, in your junior cert, we don't like sarcasm, okay? Because she's outside Lidl, okay? Is that you? Yeah, alright. Now, it's the right answer, and it's the answer we do if we're talking to each other, but you need to expand a bit on that to get full marks, alright? Sarcasm isn't worth losing a mark or two, okay? You can say that with 2 exclamation marks and then explain further underneath that if you want a bit of a laugh, alright? So, because most people are interviewing already shopping Lidl, it is more than likely that they shop there for a reason. Therefore, Lidl will be amongst their favourite supermarkets. Hence, the survey is biased. Most people said something to that effect. Is that right? Most people had common sense there. Now, lads, this one caused a lot of controversy, okay? This one in particular caused a lot of hassle. Now, I sort of let you off with this one reasonably well, but we'll see. What, does anybody see a bar chart or a histogram?
Bar chart.
Histogram. What is the difference between a histogram and a bar chart? Spaces between them. So bar charts specifically have spaces in between them. And histograms are usually used for what? Intervals. See the way 0 to 10 has about 11 people? 10 to 20 has? Anybody? 10 to 20? This region here? Has 15 people. 30 to 40? Now, let me explain what they're trying to do. Mary wants to show that about half of our example spend less than €40 a week shopping. Now, let me explain what I mean by half the sample. Half the sample be less than 40. Shade in this region, shade in this region also counts, and this region also counts. How much of the circle have I shaded in? Roughly half. This is why the pie chart is the correct answer. The pie chart shows that anywhere from 0 to 40, when you shade it in, is roughly half the size of the pie chart, hence half the population, half the people. Let's try the same trick with the histogram. 1, 2, 3. Is it really easy to tell that that is exactly half?
No.
That's your answer, isn't it? Okay. Alright, next one. Next one's really easy, okay? So, once we're done with that is, Mary wants to show that there were more people shopping in the 30 to 40 group than say any other. Which graph do you think she should use? Look at this, okay? 30 to 40 group in the pie chart, we'll colour it in reds. The 40 to 50 group, which is its closest rival, we'll colour in blue. Can anybody tell which one's bigger?
No.
I'm struggling. Okay? However, if I do it here, anybody tell which one's taller?
Yeah.
So why is the histogram the better choice? Histogram clearly shows which one goes the highest, hence has the highest amount of people in that region. That makes sense? 5 each.
I said it was a bar chart you gave me.
Which question? Shh. We have here, guys. Shh. James, using a tree diagram, show that the possible outcomes attained when 3 coins are tossed. Is it 3 coins are tossed or oh yeah. Coin 1. So excuse me, we're going to have coin 1, coin 2, coin 3, okay? So, yeah. Okay, so your first toss, it goes 2 ways. What can you get? A head or a tail. Your second one? Another head or another tail. Your third one? Anybody? Another head or another tail. Now let me explain what's happening. Because you tossed 3 coins, yeah? How many different outcomes are you going to have? You're going to have 3 different results. You could have a head, followed by a head, followed by a tail. You could have head, 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 couldn't you? Tail, tail, tail. Anything. So here's what a tree diagram does for you. Looking at this, 1, 2, 3. Head, head, head. 1, 2, 3. Head, head, tail. Head, followed by a tail, followed by another head. Do you see what I'm doing? Just keep going down different routes. Head, tail, tail. Now you're starting off with a tail. Tail followed by a head, followed by another head. Tail, head, head. Tail, head, tail. Tail, head, head. So was it? Is the zoo tail, head, head? Yeah. Oh, so that should have been tail. Excuse me. Tail, tail, head. After tail, tail, head. Tail, tail, tail.
So is head, tail, tail the same as tail, tail, head?
Where? Head? No. Different coins.
Alright.
This one is the first coin got a head. the second coin got a tail, the third coin got a tail. Well, tail, was it tail, tail, head that you're saying is? Or tail, head, head?
Yeah.
First coin is a tail, second two are heads. So lads, how many outcomes do we have? 8. Another way of doing it would be, another way of counting how many you have. You have 2 outcomes for your first one, 2 outcomes for your second one, and 2 outcomes for your third one. Anytime you toss a coin, how many different results are there? 2. The fundamental principle of counting states that if you have n way of doing one thing and n way of doing another thing, you multiply n by n. In this question, we have 2 results followed by another set of 2 possible results followed by another set of 2 possible results. 2 by 2 by 2, 8. All 8 different results are located there. Okay, I'll give you another example. There's another example down here. Predict the number of outcomes when 2 coins are tossed and a fair die is rolled. How many outcomes are there from the first coin? How many? 2. Second coin? And a dice. 24 different outcomes. Can we list all 24 different outcomes? Ready? Okay, I might type this up actually because I'm feeling a bit sorry here. Okay, ready? HT1, HT2, HT3, HT4, HT5, HT6. What does that mean? Head, tail followed by a 1. Head, tail followed by a 2. Head, tail followed by a 3. Okay. What about head, head 1? Head, head 2. Head, head 3. Head, head 4. Head, head 5. Head, head 6. Everybody happy with that? What else can happen? Tail, 1. Tail, 2. Tail, 3. Tail, 4. Tail, 5. Tail, 6. Anything after that? I did head, tail. What did I want to do? Tail, head. Tail, head 1. Tail, head 2. Tail, head 3. Tail, head 4. Tail, head 5. Tail, head 6. Add them all up. How many do you have? 24. And you're done. Only